Some minutes start. Paper number 24, ready? The second. Elena?
Yes, I'm ready.
Thank you very much. So, have your camera?
Also, participants should turn on the cameras during the presentation.
Thank you very much. Paper number 28, ready?
Yes, I'm ready.
Would you please also turn on your camera during the presentation?
Not now, but during your presentation, it's the requirement of IEEE, turn on camera. So please follow these instructions. Paper number 40.
Okay.
Oh, thank you very much. So paper number 41 here. Paper number 31 more here. Okay. So 5 minutes. Not 5 minutes actually.
Welcome to the IT very important also conference. Good luck. Hopefully we will have people presentations today. So, and I think we can start with the first ID. 21, Professor Victim.
Yes, could you please tell louder?
Yes.
So you can start.
Okay, we
You
have
can
7
see-
minutes, I think, right? Okay. 1 second. Good afternoon, dear participants of the conference. My name is Yerkin, and I am assistant professor at Nazarbayev University, Astana, Kazakhstan. And today I would like to present our paper, Statistical Analysis of the Pector Intercostal Fascial Plane Block on Pain-Related Outcomes in Cardiac Surgery, on behalf of my colleagues, Fatima and Dmitry. So, effective management of postoperative pain is a primary objective in hospitals, and there are various methods to reduce pain after surgery. One of them is a Pector Intercostal Fascial Plane Block, and it is a new regional technique used to block pain after cardiac surgery. So block here means that some kind of medicine delivered to the muscles locally after surgery to reduce the pain. So it blocks the nerve responsible for supplying a sensation to the skin, soft tissues, and sternum, and reduces the pain. However, this block was not studied very well systematically. So the aim of our work is to conduct statistical analysis, so-called statistical analysis, or so-called meta-analysis of this block based on studies from different countries. In other words, in different countries, were done some studies in hospitals, and in this work we aggregate such kind of information, conduct statistical analysis to see, is to evaluate this block in terms of pain reduction, in terms of postoperative opioid consumption, and length of hospital stay. So pain intensity reduction is a primary objective, and the other two are secondary objectives. So here are some abbreviations used in this work. Basically, I will tell about them later, but but we should have it here. So methodology starts with search of the literature in databases like PubMed, Google Scholar, Scopus, and the Cochrane Library. And we conducted that before December 28, 2023. Okay, so let me use here a pointer. Okay, maybe I can find it later. Okay. So, and in this work, we used adults, patients of age 18 or older, and we used study types, randomized controlled clinical trials, which are basically the highest level of evidence in medical research, studies published in English, and surgery types about cardiac surgery, and comparators. We have block and no block groups, 2 groups, and we use software Revman. So here a short flow diagram of our search, and we found 3 studies that were relevant to this study. Okay. So 3 studies satisfied our search criteria, and we checked methodological quality of included studies on the Jadat scale, and they were good. As you can see, here 3 studies from USA, India, and China. And in studies, normally they should describe randomization process, and all of them describe that. They used a randomization process. They should properly describe them. Study should be double-blind. In other words, patients do not know in which groups they are, in block group or in the no block group or control group. And also, nurses do not know patients in which group. Okay, only doctors know and researchers. Study should also describe methodology of double blindness, description of withdrawals, and for each point they receive 1 point. So maximum 5. As you can see, all studies are good. So in more detail, we have here study goals. You see, as you can see, primary outcome slightly differs in these studies, like in first one, opioid requirements, in second, pain, in third, pain. Okay. Okay, so here are some number of patients in 2 groups and other statistical data. I guess I don't have much time to go over this. So let's move to the results. So first result is about pain intensity. As you can see, we should reduce the pain, right? And pain is usually measured on a 0 to 10 scale. Usually after the surgery, nurses ask, how do you feel today? And do you have a pain from 0 to 10? How would you scale? And patients say, okay, 5, maybe 7, 9, whatever. And in each group, we have to calculate sample mean. As you can see, for 2 studies here, we have sample means and sample standard deviation, total 40 patients in experimental group in first study, 40 in control, and 20 in the second study. So as we can see, here is a forest plot. And it shows that both studies favor experimental group. In other words, patients in the experimental group have lower pain intensity after the surgery, comparing to the control groups, which did not have this block. And we are 95% confident about that. So our results are statistically significant. As we can see, this total study result, basically black diamond, does not cross the line of no difference, this is 0. And the green rectangles basically represent study mean, and lines they represent 95% confidence intervals. So they do not cross this line of no difference. So which is very good. So in other words, block reduces pain intensity after the surgery. How about opioid consumption? So for opioid consumption, we see that some studies favor experimental group, and one study, Zhang, actually favor control group. So in other words, we have some heterogeneity, which is measured by I-square here, 97%. And our result, overall result of this study, black diamond actually crosses the line of no difference. So in other words, there is no kind of difference in terms of post-operative opioid consumption between these two groups. And length of stay at hospital after the surgery. Here we have two subgroups. One is intensive care unit. In other words, in intensive care unit, there is no difference between these two groups.
I think it's time.
Okay, and in the control group, we have some sort of better result. So in other words, pector intercostal fascial plane block is effective in reducing pain, but more studies are necessary in terms of other outcomes, medical outcomes. So there should be some future research done in hospitals regarding this block, because 3 studies are not that kind of, enough. Thank you for your attention. Please let me know if you have questions.
So thank you, Professor, for your presentation. I have one question.
Yes.
In your result in the first page, you mentioned that the pain detected from 0 to 10.
Here?
Yes, in pain.
Yes.
Okay. And the question is, did you collect this information by yourself? And do you have any information, like to what extent you have, for example, for 0, for 1, for 2, for 3, and so on, like separating information about that?
I didn't hear well. You said that do we have separate information for each study or what?
Yeah, for each study.
Yeah, so each study, here you see each study has reported mean and standard deviation for each group. Okay, so 5.4 sample mean for experimental group and 5.8 for sample mean in the control group. So in other words, sample mean is less in the experimental group. Okay, in other words, patients who are in the experimental group who received that block basically expressed lower pain intensity compared to the control group who did not receive this. Okay, and sample standard deviations are similar, 0.3, 0.3. But now in second study, we see that sample mean is 0.3. And in the control group, we have 1.15, which, as you can see, moves these green blocks to the left of the indifference line, favoring experimental group.
Thanks for your answer, Professor.
Any questions from our auditory? Maybe online listeners, participants? No question. Okay, thank you very much, Professor, again. And we should mention that our reglement 7 minutes for presentation and 3 minutes for questions and answers. Thank you very much. So please, Gorda Elena, and co-authors present.
Yes, but I have a DOS, DOS for demonstration.
Say,
Dear participation on the conference, we bring to your attention the article Cognitive Technologies for Determining Objects and Topology of Information Space of the Domain Environment, which has a what?
we don't,
We cannot see your presentation. Could you please share?
Yes, you should share your screen. In Zoom meeting, you have this button, green button, share screen at the bottom side.
You see?
Yes.
yes.
We bring to your attention the article Cognitive Technologies for Object Detection and Topology of the Environment Information Space, which is a continuous last year work ontological analysis of cognitive information technologies of the subject areas. The purpose of our work is ontological analysis of cognitive information technologies of the subject area in order to build a formalization of description of information units. I don't read all text. You see our purpose and our achieved goals on this slide. Next slide. On the third slide, define the formation of information space based on the intellectual environment of the subject area and the intellectual information environment of the software by generalizing concept and introducing relationship based on the ontological approach. On the fourth slide defines the concept of cognitive information technologies as technologies specifically focused on the development of human intellectual abilities and the essence, the establishment of relation between an information object and software ontology. Intelligent information technologies, IIT, take into account the specifics of the problem area, which can be characterized by the speed of decision-making in the presence of multiplicity of factors and chaotic behavior of the environment, unclear goals, and non-explicit information. The information channel is the basis on the perception on the properties of the environment. The recording of information is realized due to the specificity of perception of the repeatability of the event. The properties of the environment due to which an information unit is distinguished include division, auto-semantization, pragmatism, and coherence, coding and activity in the information environment of both concepts and forms of their expression. On this slide, the essence of CSI is to establish the relationship of an information object with the ontology of a subject area. we present definition that describes of the subject area, and on this definition we define ontology of the subject area. In this slide, we can view the role and place of cognitive technologies in the subject area. The role of cognitive technologies is the connect chain between SA, ISE, IS, IIT, and the information space, and formate information space. The basis of cognition in the topology of information space we can see on this slide. The ISA technology provides for ISA space carriers, ISA-SC elements through concept and information sources in the ISA-ST element properties, declarative elements, capacity, instances of properties, information sources, and we can use the concept of element neighborhood in SAC and SAC. In this slide, we can semantic connectives of information unit that is based on the identification. We can see process formalization, from formalization to formate categories. In this slide, we can see the process of formation of information objects in PKE. Mistake CI. We get information from our cognitive channels. Then in the process of
1 minute remind.
I very bad hear you. Now we have a very bad internet, and I very bad hear you. We can see the process of formation concepts. In this slide, we define topology of the ISE and formalize this definition. And conclusion. Now we very bad internet, and we can see all our conclusion according to our task and purpose. Thank you for your attention.
Thank you very much for your interesting presentation. So only one question. How many classes in your ontology, and how many instances how many instances are marked to these classes?
The number of
Uh,
classes of our ontology define the subject area. According to subject area, the number of classes may be different. It's a general. It's a general view on the information space according to ontology theory, and it's a main describe a main formalization, and in our main formalization we describe topology, scheme of topology, information space, intelligence information space. Now we create ontology of process of learning, and in this process of the learning to get knowledge, we have 3 big classes. For example,
Thank you very much. Again, so the next presenter is paper number 28.
Did you see my screen?
Not yet.
What about now? Please, can previous participants turn off the sharing screen, because I cannot do this.
Elena, please stop sharing your screen.
yes.
Can't moderate the notes. Can't moderate the notes.
Elena, please stop translating.
It's ой-ой-ой. I stop my demonstration.
We can see your screen.
Thank you very much. So the next presenter is Aisha Kozensitova, Astana University.
My screen? Did you see it?
Yes, see and hear you.
Okay. Good afternoon, dear participant of conference and organizer. The paper is Development of the Method of Blood Clot Origin Classification in Ischemic Stroke. Let's start with introduction. The study introduces deep learning method aimed at refining the classification of ischemic stroke etiology. The method is designed to accurately classify the origin of blood clots, which is cardioembolism and large artery atherosclerosis. First, what is ischemic stroke and its origins? Ischemic stroke, sudden loss of cerebral blood flow due to an obstruction within a blood vessel supplying brain, which means blocked blood vessel. This leads to loss of neurological function and accounts for approximately 87% of all stroke incidents globally. And the first origin is cardioembolism, is the formation of an embolus in the heart, which subsequently dislodges and enters the cerebral circulation, causing a blockage, which we can see in this video. And the next, unlike cardioembolism, large artery atherosclerosis involves the formation of the atherosclerotic plaques in major arteries supplying the brain, such as carotid artery. Here in the video also we can see how the plaque is formed in the artery, which is causing the blockage. So the objectives are developing a robust deep learning model capable of classifying ischemic stroke origins with high accuracy and validating the model's effectiveness using a standard medical imaging dataset. Let's start with methodology. First, it's our dataset. The Mayo Clinic dataset used for classification of blood clot origins, dataset from Kaggle. And the dataset consists of images categorized as either cardioembolic or large artery atherosclerosis. Here, the more in-depth look at the dataset. Training set dataset contain 754 high-resolution whole slide digital pathology images in TIFF format, represents blood clots from 632 patients across 11 medical centers. Here in the first picture, we can see how distributed images for 11 centers, and each patient could have up to 5 images. Images are labeled as either cardioembolic or large artery atherosclerosis. And in the second picture, we can see how per overall images for cardioembolic and large artery atherosclerosis. So here the one of the pictures of cardioembolic blood clots, and this here the large artery atherosclerosis blood clots. Next, after seeing these images, we can see that we have some challenges for preprocessing it. First is high resolution images. Some images sum up to like 2.5 gigabytes. It needs a lot of power, a lot of memory. Also, image resolution for classification. For more efficient classification, we need resolutions, for example, 512 for 512 pixels. Also, we have a lot of empty spaces in the pictures, if you can see. And due to the number of the images, we can have a risk of overfitting. Also, we have different background color variations, each challenges of isolating the needed areas from the image. So how we solved it? Here, the methodology of image preprocessing. First, we read and crop it. For that, we used OpenSlide library for reading the image. Then we select a specific region from the original image. We select some coordinates to do that. After that, we convert it and resize. The cropped regions are converted to an RGB format and then resized to a fixed size or that we choose before. We use for that OpenCV. And here, like example, how we can first input image, then we crop it, and then we convert to RGB. Why we convert to RGB? To make it more clear, visible for model. So our model training, we utilize a sequential convolutional neural network, a model from the TensorFlow Keras library for the classification task. Here in the picture, we can see all the layers, step-by-step sequential CNN model architecture. In short, we have convolutional layer, which have the varying filter sizes, also the kernel and batch normalization pooling layer. This layer is designed to extract features from the input images, and then we use flattening fully connected layers. After convolutional layer, the model is flattened and passed through the dense layers, regularized to prevent overfitting. And output layer, we have the sigmoid activation functions, which is binary classification to give us output like if it's either cardioembolic or large artery atherosclerosis. Also, we trained our model. Training process, we preprocess images and the corresponding labels are converted into NumPy arrays. We split it into training and testing set, 80% and 20%. Also, we made a learning rate scheduler and early stopping to optimize the training process, and model fitting is trained, we model trained on the training dataset with batch size of 64 and validated on the testing set for 20 epochs. So our results, the results indicate the model's likelihood of a blood clot being the cardioembolic or large artery atherosclerosis origin. For example, our first patient here was predicted with a high degree of certainty to have a cardioembolic origin for the clot, 100%, suggesting a strong presence of characteristics typical of cardioembolic strokes in the analyzed image. In contrast, other patients exhibit more balanced probabilities, indicating a less clear-cut diagnosis and the nuanced nature of medical image classification. And the overall result, using the performance metrics of the deep learning model, we have the accuracy of 97%. And using this model, we can create the app, which we browse the image and then classify it, and it detects either it's cardioembolic or large artery atherosclerosis using our trained model. And in discussion, we have accuracy of 97%, and it is the high accuracy, which is critical for effective diagnosis and treatment for ischemic stroke. And our model tested under a variety of imaging conditions. Our model accurately classifies clumps of different types, resolutions, and backgrounds. Also, we implement advanced data preprocessing and model training techniques to manipulate high-resolution images and reduce risk of fitting in kids. So in conclusion, in the study, we have successfully developed and validated a deep learning model, specifically a convolutional neural network for the classification of blood clot origins in ischemic stroke in patients. So is here the Q&A section. Thank you for your attention.
Thank you very much. You have shown the result about checking your model for only 4 patients. But in reality, how many patients did you use? Or
Oh, it was just an example of before the creating the app. So I have here these like supplemental other data set, which includes 396 images that is not in training set. So it just was example of like 4 patients. So I can no, I use in my applications that I made to detect from the image. I can use other.
all of your 4 patients, all of your examples are presented for the patients that are mostly of the first kind of that classification. And no one will go to the
Sorry,
second
I
type.
do not hear you properly. Can you repeat or write?
So you have shown the results only for the first classification. What about the second one?
In application, it means that I only detect cardioembolic? No,
Yeah,
the model works like that. Like we have, it just I took a video of only this part. It also detects the LLA part. Like it gives 0 ID for cardioembolic, and if it's LLA, it gives the ID of 1. And if it's not either cardioembolic or large artery atherosclerosis, it gives us -1. So model works like that. It detects also LLA and CE together. Just I here show only video of how I detected one picture. I'm sorry, but model works so it can detect either it's cardioembolic or large artery atherosclerosis.
So in your paper, you have all kinds of results. This is not the first only first classification.
Can you repeat again? I'm sorry.
So in your paper, do you have results for the second classification also? Because during the presentation, you mentioned only the first one.
In your, you have shown the result only, and you have defined
don't
only
understand, like here, with patient's probability, like, yes, I already showed that number of cardioembolic images is higher than LLA, so I randomly choose the image, so it gives more percent of cardioembolic. So that's why in my examples, it shows that all pictures are cardioembolic. No, it's not like that. I can, yes, I have a prediction in my paper of LLA cases. Just for presentation, I just randomly choose the images. I showed in pictures that like cardioembolic images have more numbers than the LLA, but model will.
Thank you. Okay. I think we need to continue with paper ID 40. Jakubova, Abilova, Asukhan. Okay.
Good afternoon, dear participants. I'm really glad to perform my work here because it's my first experience. And the title of my research is the special analysis of a Turkish earthquake in 2023. Yeah, 2023. And geographical distribution research. I'm a master's student of Eurasian National University, Astana, Kazakhstan. Thank you. Next slide. The relevance. Analyzing the Turkish earthquake using a geospatial approach provides valuable knowledge about causes of seismic activity, which will help to develop more effective measures to reduce the risks. Scientific novelty is the geographic geospatial analysis involves the integration of geographic information, spatial modeling, and seismic activity data analysis. The next slide, please. Next slide, please. Aim of the research is to perform the geospatial analysis of Turkey based on seismic activity data from the 6th to 24th of February 2023. And this work has three objectives. The first is study literature sources. The second is analyze seismic activity data and conduct geospatial analysis of earthquake. Next slide, please. Seismotectonic position of Turkey. As we know, the Turkey is located on the four lithospheric plates. There are Arabian plate, African, Eurasian, Indian, and Anatolian lithospheric plates. And therefore, such conditions imply the risk of some earthquakes. Next slide, please. And for providing and performing the geospatial analysis, I use the ArcGIS software, which creates, display, and analyze vector data, perform complex vector analysis, and fully integrate raster data based on the vector information. Next slide. So, methodology. The resource of earthquake coordinates is the USGS, United States Geological Survey catalog, which additionally reflects the area and parameters of seismic activity for a specific time. The second figure illustrates the interface of the USGS website, which we use for taking the coordinates of earthquake. The next slide. The basic information uploaded in a CSV format for for taking it to the RGS program. The next. Next, please. Okay, the figure 4 illustrates the development site where we can download all administrative regions, not only Turkey. We can download it for each countries which you prefer. And in this case, we should download only the shapefile for using the RGS program. The next, please. Here, all the obtained data is transferred to ArcGIS and is displayed for each lawyer. This is illustrated in the course figure. That illustrates the displaying the coordinates of the earthquake of the Turkey. The next one, please. To conduct the spatial analysis, I use the IDV methods, which helps to visualize the result. Next one. Here I use the extract method to extract along the Turkey. Next. The results and findings. Here, as I said, in this table illustrated the data of the earthquake. The next one, okay. And result and findings. Here is the result of the work. Here we see the visualization of the earthquake, which helps to forecast the future earthquake. The next one. And in the conclusion, I would like to say that ArcGIS is a really useful program which helps to which give us the prediction, the data integration, the spatial visualizers and spatial analysis. And in the future, skills in conducting spatial analysis for seismic activity research could be applied to forecast seismic hazards in the Almaty region of the Kazakhstan, of the Republic of Kazakhstan. So I think, thank you for your attention.
I have a question. Actually, you are working with dynamic data. So your data depends not only on the space distribution of the earthquake, but actually on time too. But unfortunately, I didn't notice in your presentation some kind of data that depended on time and how they were correlated each other and how they were related to their positions. But when you mentioned that you are able to predict the possibility of the earthquake, how the results, do you have some visual results to show that, for instance, for some points on that earth, at what point, what you could predict based on your dynamic data? And what were your data, for instance, if you analyze them with respect to time, how many data did you use to make your analysis?
Okay, thank you for your question. And I would like to say that geographical scientist has the term like geographical zoning. It's a method when all of earthquake data are joining and they are just layout to the lawyer, and this program ArcGIS can analyze it, and after that we can see that we can see the result of this analysis, and
that you mentioned the program analysis.
but the program.
Could you explain in what method, what mathematical method do the programs apply?
Okay, IDV methods. I mentioned it. IDV methods is it's like Okay, we have datas from USGS. We just lawyer it, and after that, these data are pressed to this platform. For example, for a Turkey web.
Yeah, it's clear from the
Yes.
picture. Yeah, but next, for instance, you can make some, making average of the data at some points, or maybe something other analysis that you didn't mention, the mathematical kernel of the analysis.
I don't know the mathematical methods of the.
Okay, thank you.
So maybe you're asking about it's like time series, something like
Yeah.
that. But after the relation rules,
And so on, but.
she asked me what's the basement of the model, what kind of mathematical model of time series is here, because it's a dynamical, so it should be time series. What should be in here? What kind of model is it?
I just, my result is the earthquake on the February 2023 only.
Thank you very much.
Thank you.
The next presentation is 41.
Next is me, Aruzhana Mangildieva, paper 41. Yeah. Now I'm sharing my screen. You cannot start screen share while other participant is sharing.
41, Aruzhan Amamdudiyeva.
Yes, I'm here. Can you hear me?
Yeah, share your screen.
Please stop sharing the screen. I cannot share. Yeah. So can you see my screen?
Yes, thank you.
Good afternoon, everyone. My name is Aruzhana Mangildieva, and I'm second-year master student at Astana IT University. So here I will be presenting my thesis topic on hybrid approach for a movie recommender system using content-based, collaborative, and knowledge-based filtering methods. As we know today, with rapid evolution of information technology, we are now emerging to the big data era. So it's to find the right information that we are searching for is becoming complicated day by day. So here, consequently, good recommender systems with higher accuracy are playing important role in our world. According to a study done by Brilliance in 2020, product recommendations could increase in income for 31%. It shows that how important the recommender systems for business too. In movie recommender systems, mainly today's the most popular methods are content-based and collaborative filtering. In my thesis work, I'm going to integrate also knowledge-based recommender system to get higher accuracy. Today, I will be showing how I reached the results. Here I used singular value decomposition method for content-based recommender system, nearest neighbors for collaborative filtering, and matrix factorization with transformers for knowledge-based filtering methods. So let's jump through my methods. What about data collection? Here I used MovieLens dataset with 100,000 data. Here's some information about this dataset. So what is content-based recommendation system? It uses, as it says, content, it uses item features to recommend it for users. For example, if Alice likes comedy and he disliked criminal movies, so comedies like Mr. Bean, Always Say Yes will be recommended for her. Advantages of content-based recommender systems are no need data about other users. We only need what the user did in the past, what movies she liked and she disliked, what movies she watched and for what time, and so on. And we can recommend niche items. If she liked comedy, we can recommend only comedy. Actually, it's also a disadvantage because if she has never watched before biography, so we cannot recommend some new genres for her. And there is need for domain knowledge. What about collaborative filtering? Here we look at the patterns. Here we, for example, if user A liked movie 1, movie 2, movie 4, and movie 5, and user 1 liked movie 1 and movie 2, here we see that there is 50% of similarity, and we will recommend movie 4 and movie 5 to user B because it has similar patterns with user A. So here also we don't need any domain knowledge. And it's a great starting point for users. And however, there is a cold start problem. It means that if you have a new user that that she has no any pattern, she's new user, she didn't watch any movie in our service, we don't know any information about her. So in these cases, we can use knowledge-based filtering method. Here, for example, while user registering the server, she filled the form that she's from Kazakhstan, she's a woman at the age of 20, and so on. So we can use this information to recommend her Kazakhstani movies, movies for girls, and so on. So here, my problem was to eliminate all the disadvantages and take only advantages of each method. To do so, here I can show my code actually. Here I prepared my data. Mainly I used surprise library of Python because I think it will be easier to explain by presentation. For content-based filtering, I used k-nearest neighbors using cosine similarity. High similarity means if cosine is close to 1, it means higher similarity. Here we can see example, Incredibles and Spider-Man's vector. Here I demonstrated how I calculated the cosine for them, and it showed 0.71, and it means that it's quite similar to each other. It means that we can, if you have seen these movies, we know that these movies are really similar to each other because each of them has a superhero that helps the world. The next is collaborative filtering. Here I used singular value decomposition. I divided the matrix.
Please. 1 minute.
Okay.
Sorry.
And for knowledge-based, as I said before, I used transformers, matrix factorization. Here is neural networks. I trained my data, and in the 7th step, I got similar data that I was expecting. And here we can see in this table, we can see the results of each method. CF means collaborative filtering, content-based, and combining collaborative and content-based, and combining content-based, collaborative, and knowledge-based. Here I calculated root mean square error, mean absolute error, and fractional concordant pairs for each method. How RMC Maya is lower and how FCP is higher, it means higher accuracy. So as you see here, my results were were quite
Please conclude.
accurate. Thank you. Do you have any questions?
Thank you very much. Your use algorithms that all of them you develop yourself.
Content-based and collaborative filtering methods are used mainly in today's recommender systems. Here, the novelty is combining knowledge-based method to these methods. I haven't found any information about combination of exactly these three methods, so that's why I think that this new method.
I mean that you didn't compare with known baselines since these all algorithms work on your data and you compare algorithms only with your own developed code.
The methods are existing in the world from the beginning of internet. Actually, here I showed how I used these methods and how I increased the accuracy of these methods on my own by adding knowledge-based method to existing content-based and collaborative filtering methods.
I mean that if you want, if you prepare your
Whole code
if you
was written by me. Here I also added in appendix my own code. This all code was written by me.
Thank you very much.
Thank you. Goodbye.
Please ID number 46. Nelly, we see you.
I would like to thank the organizer and the students for the opportunity. We thank you for coming. I present the report and something.
Please turn on your microphone. We can't hear you.
Sorry, Professor Asubekova, we cannot hear you.
Nelly,
Yeah, I'm here.
Вас не слышим. We are not able to hear you.
are you hearing us? Nelly, вы нас слышите? А мы вас нет. Houston, we have a problem.
I hear you very well.
Okay, paper number 49 here. While Nelly prepare your her microphone, please, paper number 49. 49. Нурсултан Жанкелев, Серик Оспан. please.
Hello, can you hear me?
Eric, share your screen, please.
Please, 1 minute.
You cannot get it. Are you here?
Yes, we hear.
Yes,
Yerkan,
I'm-
please.
Yes,
Can
I'm
you
here.
Can you start your presentation while other participants prepare?
Okay,
Thank you
okay,
very
no
much.
problem. Okay, let me share my screen. Yeah. Okay, good afternoon, everyone, again. So my name is Yerkan, and together with Dastan, Miram, and Dmitry, we worked on statistical analysis of outcomes of basivertebral nerve radiofrequency ablation for vertebrogenic chronic low back pain management. So these days, a lot of people suffer from low back pain, especially if you sit in the office long hours. You may have low back pain, and it may be chronic if you have such kind of pain more than, let's say, 6 months. After 6 months, it's considered chronic low back pain. And one of the treatments is intraosseous basivertebral nerve radiofrequency ablation. In other words, just radiofrequency ablation. And this technique was not well studied. And our goal is to study this technique in a systematic way. So in other words, here you see one image, MRI image of patient, with low back pain. And here you see some kind of damages, right? And after, 6 weeks of treatment and 6 months of the treatment. So aim of our work is conduct statistical analysis of radiofrequency ablation based on randomized controlled studies. And we want to evaluate pain intensity as well as disability, pain-related disability. Here are some abbreviations, and most of them we'll discuss during the presentation. So in our study, we used databases like PubMed, Scopus, Google Scholar, and Cochrane Library. And we searched for studies, and our search was conducted on December 26, 2023. We found 7 relevant studies. These are randomized controlled trials. Inclusion criteria included like patients of age 18 plus, randomized controlled trials in English, disease low back pain, and radiofrequency ablation versus standard care. So from out of these 7 papers, 3 did not have relevant data for our meta-analysis, so we included only 4 studies. Here are the 7 studies, and in green we see that 4 studies which were included and three studies in red, which were not included. As you can see, these studies were not good in terms of randomization, double blindness, and so on. So they received lower methodological scores. So here are some description of the studies in terms of age, mean and mean range or mean standard deviation, number of participants, what groups they had, BVN and sham controlled, BVN and standard care, basically BVN and standard care, right? So these are, and diagnosis, basically chronic low back pain. First question is that radio frequency ablation reduces pain or not? Okay, so after the radio frequency ablation, patients were asked what is the pain intensity level from 0 to 10. And according to the studies, in preoperative stage, so before the treatment, we had, as you can see, overall, there was no much difference between BVN group and control group. And after treatment, that is postoperative period, we have a clear difference between pain intensity in the experimental group comparing to the control group. So control group patients did not receive anything except standard care. And in the BVN group, they received radiofrequency ablation, which reduced the pain. Okay. And another result is that we checked how this radiofrequency ablation relates to disability. So there is a disability index from 0 to 50 scale. And before the treatment, as we can see, there was no difference between these two groups because this black diamond crosses the line of no difference. And in post-operative period, we also see that this black diamond basically crosses the line of no difference. So, but we see that it moved to the left, right? So,
The left,
towards,
sorry.
yes. Questions? Hello?
Thank you very much. Questions?
Ah, okay, thank you.
Do you have questions? Excellent work. We have no questions. Thank you very much.
Okay, thank you.
So the next presenter, Nelly. Nelly, are you here? Okay.
Can we demonstrate our research?
Yes.
Sultan. 98.
Could you please turn on your camera also?
Personally.
Sultan, can you please share your presentation and turn on your camera so we can start your.
Do you hear me? Hello.
We can hear but we cannot see you.
Ah, okay. One minute.
Page.
Hello, everyone. Do you see me? My screen and me?
Yes. Just
Ah,
start, please.
Hello, everyone. My name is Nurstan. I'm a master student of Kazakh Technical University. My research topic is classification of Parkinson's disease. And so our research topic is a comparative study of supervised machine learning and the deep learning techniques with feature selection made for classifying Parkinson's disease based on speech impairments. Next, please.
You need to scroll.
So first of all, we were talking about introduction. So at the moment, in the world, 1 million people suffer from Parkinson's disease. It's very complex and it's very important to identify in early stage. At the moment, the most popular way to identify this disease it's using MRI of the brain because there is one substantial negro which provide us dopamine hormones. The most recent of the Parkinson's disease researcher says that it's lack of dopamine hormones, and after this lack of dopamine start the first symptoms, and one of the first symptoms is speech impairment, and we use this speech impairment as pattern for classifying Parkinson's disease. And in our research, we focus traditional machine learning and deep learning in order to classify Parkinson's disease, and we explore different feature selection methods in order to show potential of each feature selection method with different machine learning models. So the first of all, we were talking about our methodology. The first is dataset. We implement the dataset provided by Department of Neurology at the Karen Paya Faculty of Medicine, Istanbul University, and they extracted, in order to extract the data, they used a lot of method. For example, the first method is baseline feature and the male frequency feature and the vocal fold feature. So our data set consists of 744 feature and 756 instances, subjects of Parkinson's disease. Methodology, the second is we use data preparation and feature selection methods. First of all, we use normalization metric using min-max scalar because it's help us to put data between 1 and 0. It's very comfortable for machine learning model in order to understand the data. After that, we use principal component analysis in order to minimize our feature. The second is minimum redundance, maximum relevance, and the select best. And in machine learning approach, which we use in our research, is algorithms, logistic regression, decision tree classifier, and the random forest classifier, and the super vector machine, and the key neural neighbors, and the Gaussian knife bias. And the deep learning approach, we implement one-dimensional convolutional neural network because it's our data set is not image, our feature from speech, and we decide to use one-dimensional convolutional neural network. After that, we use deep neural network, second deep learning model. As you can see, this is our one-dimensional convolutional neural network. We get from the architecture get from the research. It's young, and their one-dimensional convolution neural network with 10 convolution layers achieved an accuracy 84. In our case, our accuracy in our sample one-dimensional convolution neural network with 2 convolution layers shows the best accuracy with 88 with specific selection. This is our methodology. This is our evaluation methods, which we use in order to know how to machine learning models works, accuracy, precision, recall, and F1 score. This is our result. As you can see, the best recall was achieved by random forest classifier. Recall, it's most important metrics in medicine because it helps us to find the really people who has this Parkinson's disease. And the second best accuracy was achieved with PCA, filter selection, and the machine learning models, KNN. And the precision also, KNN was achieved the best results, 93. Review of current research in this area. For example, we comparative our results with other research. For example, Kasia Ahmed was achieved the best accuracy 91. In our case, our accuracy was achieved 93. And the best precision and our precision showed good results. For example, 93. So conclusion in our research, the KNN is more accurate and effective machine learning models for classification pattern disease based on speech impairment. And the PC algorithms is more reliable filter selection than MRMR and the Silka based for classification pattern disease based on speech impairment. And at the moment, the machine learning models also still reliable approach for classification pattern disease. Reference. Thank you for your attention. Do you have any question?
Thank you for the
Thank you.
presentation. So you can go to the, I think, second or third page where you mentioned about 90% of impairments. So and you were saying that 90% of people who struggles with Parkinson's disease has impairments. But do you have, as I know, there are 3 classifications of Parkinson's disease also. So, and do you have like the expertise like with different classifiers? I mean, like the first cluster, the third cluster, or are you considering all of them as one?
Can you again, please? I didn't understand your. Second presentation page. This is this page?
We do not see your second page. Please,
second page.
On the page of the presentation is not
This is my second page. Introduction.
No, we see the last page, not the second one.
We see only the last page of your presentation.
Okay. Okay. Please, yeah.
So actually, it's not
okay. So introduction or methodology about data set.
Before 90%, before introduction.
The previous one, the previous page.
Oh, so yeah. So here you are mentioning that speech impairment are observed in 90% of patients with Parkinson's disease. As I know, Parkinson's disease has like 3 classifications, like the first one, second one, and the third one. So did you, for example, I'm sure that the first cluster don't have like speech impairment, the second one maybe partially, the third one is mostly affected. So do you have like, did you do the experiment separately? I mean, like, did you apply your machine learning, deep learning separately?
Could you please write your question in? I cannot hear full.
Okay, so I think you didn't do this kind of thing, okay, so it's just a suggestion, so it will be good for the patients who have Parkinson's disease. So if you apply separately for the first class and for the second and the second, because I'm sure that not all Parkinson's disease people have speech impairment.
Честно, я вот этот звук ваш не очень слышу. Можете написать?
So the question is, she says that,
О,
do you hear me?
ага. Yes, yes, of course.
Yeah, so she says that there are three classes of this disease, as I understand. And
Yes, of course. I'll
question
yes,
is, did you use your method for one of them or for all of them? Kind of, because they have different kind of, precision, right?
Yes, of
So,
course.
depending on the disease level.
First of all, we focus on the speech impairment, and we use this method only one class.
Okay,
So which class is that, like initial level of the disease or
No,
middle
no,
level
no.
or
Only
latest level?
yes, I understand you. So I have only two classes. The first class is the people who has Parkinson's disease. The second class who has not Parkinson's disease. In the data set, there are not any category of symptom of disease, for example, initial, second, and third.
I see, okay.
Okay, thank you very much. So now coffee break, and Nelly, please, 20 minutes, please prepare your microphone and prepare your camera. After the break, we start with your presentation. Yeah. Please tell us something.
Good afternoon.
Uh,
Can you hear me?
Can you share your screen and can you turn on your camera? So we have some problems without projector, so we need somebody who can present online.
Sorry, can I ask?
Yes, what's your question?
I think it's my turn to present my presentation, not Tia's. So by the schedule, I think it's my turn. It's ID 70.
Yes. From CD,
Yes. Hi.
But before the break, okay, we didn't finish previous three presentations. So first of all, we need to finish, then we can continue, okay?
Yes, sure.
John Sari, are you online? So we have that you in person.
Yeah, I'm sorry I couldn't visit today. I get sick, so I couldn't visit.
That's your turn. So if you turn on your camera and share your screen, we all thank you very much.
Yeah, hi. I'm ready.
Please start
Okay.
presentation.
Okay, let me go back and start. I think you can see my screen now. Hi everyone. My name is Janseri Kram. I'm a PhD student at Kazakh National University, Almaty. So my topic is hybrid deep neural network for face liveness detection in real-time video. Here, yeah, let's go on. So the background and motivation since the COVID pandemic has accelerated the adoption of contactless biometric systems. It's also we need to also be sure that we are secure during this process. So that's one of those motivations. The second one is there is a pressing need for the algorithms capable to generalize across different demographic groups and environmental scenarios, because current algorithms don't work very good. So still a lot of companies that work on biometric identification can be hacked easily. So the third point is algorithms must not only learn better from diverse data and adapt across conditions, but also operate efficiently on mobile devices. So your algorithm should work fast. So that was my motivation. And so let's move on. So why FAS? FAS is face anti-spoofing, or we can define it as liveness. Why this is important? So let's show the process. The process is like the attacker wears the mask of the victim. So he or she prints the mask, 3D mask, wears the hat, and tries to pass through the face recognition. So it goes to the system, shots the face, and the system says match, and the hacker or attacker can easily get access to bank account or eGov of his victim or etc. So the data set here that I used is Oulu MPU. It's our colleagues from Finland University, from Finland, Oulu University. So they provided us with about 5,000 videos of 55 subjects and different devices from frontal cameras and printers display to demonstrate print attacks and replay attacks. I will explain now what are they. So let's see. So in order to train, test our methods, we need to have the live version of a person. Then we need then we need print. So the print is when you print the victims through the printer and shot to the camera, and the replay is when you shot to the video in other devices display. So that's called replay attack. So this data set provides us with live, print, and replay, 3 types of classes. But here we just use binary classification since we need to define whether this is live or fake. So let's move on. So the losses here that I optimize is binary cross entropy loss and mean squared error. I will explain here what are they actually mean. So here I mainly used EfficientNet v2 backbone to EfficientNet v2 backbone to use in my model. So here I use 2-branch method, and the first one is actually already pre-trained model on ImageNet dataset, and second one is the Fourier transform Fourier transform branch. So so my model generally tries to restore the map of the of this photo, and tries to get Fourier spectrum map. And I use mean squared error to recreate this map. So the second one is binary cross entropy with log-gate slots, which that's used for classification. So the total loss is the average of the binary cross entropy and mean squared error. So I try to minimize these losses. So this is my experimental setup. I used 4090 GPU RTX. Then I used optimizer as ADAM optimizer with batch size 32 and image shape 512 and 8 frames per video, since it's more efficient, not more efficient, more robust to average different frames rather than one. Yeah. So this is my results. I used 2 protocols here in my method. So the first protocol tests for the lightning and background changes. What will happen if we change lightning and background using our data? So the second one is what will happen if we add new devices to our data set. So will it be still working, our method? So here you can see the results. I use dynamic thresholding. As we know, by the change of threshold, the metrics also change. So if we raise the threshold, the APCR metric will decrease, and etc. Yeah, this is my GradCam results. This is a gradient activation map where the model actually looks. So finally, the inference looks like this. So 8 frames one by one pass through the phase detector and phase and spoofing model. Then I average these probabilities. So at the end, I adapted the efficient net framework to design a new architecture, better model accuracy through Fourier spectrum guided training method, GradCam heat maps to visually clarify decision influencing region in images, and achieved one of the contributions is like I achieved the rapid processing capabilities with 8 frames by the efficient network architecture. So that's the end. Thank you for your attention.
Can you hear us?
Yes. Could you speak louder, please?
Thank you for your presentation. So I think we don't have questions regarding the methods and conclusion part, but the only question from my side is, you said that you are collecting the data set from your other universities when you were being country.
Yes, this is actually a very popular data set in my sphere. I mean, in liveness detection, I just wrote the application form, signed, and sent to them, and they sent back. So I cited them on my paper here.
And you to collect your own data set?
It's actually difficult to collect your own data set because you should first anonymize. Second one, you should people will not agree to show their videos. They don't know if this data set go to the third party, yeah, and it's really difficult to encounter the leak.
Thank you very much. We understand. Thank you very much.
Thanks for your presentation.
Thank you for listening.
Next presenter,
ID 68,
please.
Hello, everyone.
No. Yes, sorry. So first of all, we need to present the 2 presentations, what is left before the break. So then we will call you, okay?
Sorry for confusion.
Yes, 1 minute.
No, should we start?
No, just Sorry, I mean like, before the break, we have 2 presentations left, so they need to present now, then we will call you, okay?
Sorry for confusion, Diaz.
But can you speak louder, please?
So we are saying that you need to wait the 2 presentations, after that you will present, okay?
Окей, окей.
Диаз, простите за путаницу, Диаз. Просто получилось так, что у нас была выключена. Сейчас вот как бы они выступят по очереди, потом ваша очередь. Спасибо. за
Хорошо, окей. Окей, хорошо.
So I think it's time to start for us. So hello everyone, I hope you're doing well. So my name is Mohamed Ruslan and my colleague is Tikar Samarat. So our chosen research topic is enhancing gameplay experience through the reinforcement learning in games. So next slide please. So today our presentation of research contains the introduction, objectives, problem statement, which review, methodology, and the results and discussion conclusion. Next slide. For the introduction, it's important to understand those terms that display on the screen. So, and let me tell you briefly how reinforcement learning is implemented in our project. So, agent, which is artificial intelligence learner, makes random numbers, and we will convert it to the actions: go forward, go to left, or turn right. So based on these actions, agent gets a reward. Reward can be negative or positive. And of course, our agent learner tries to get maximum score and get maximum positive like rewards. So, and based on his knowledge and experience, do make new actions. So next slide. Let me tell you about the initial aims of our project. Our aim was to study AI with the reinforcement learning and study possibilities gameplay experience. So we said to achieve this goal, we set 3 objectives. First is trial algorithms in simulator, which is our game. Develop AI-based agent using Unity's library. 3 is train-based AI. Next slide, please. Problem statement. What is our problem that our project meant to solve? Is boring NPCs or non-playable characters. Here's our stated research question: how can reinforcement learning algorithms be used for non-playable characters or NPCs in games, and what impact will it have in player engagement? Next slide.
So for the literature review, we have got some several articles that are based on the same topic of using the artificial intelligence in games, and there are the ones what we want to mention. The first one, the author compared the basic AI, game AI, and AI with the reinforcement learning, and the main thing that he concluded was that even if the AI was playing as a professional level, at the professional level gaming, he was very difficult to and costed a lot of resources, and AI decision making was very hard to control because of imperfect punishment mechanism. Next one. In the second one, the authors tried out some experiments with the behavior cloning, and main foundation was that the behavior cloning was affecting negatively, and the agent without behavior cloning was performing better in game. Next one. In this article, the authors tried game AI inside a 2-dimensional football game, and the main problem that he found out was that the AI agents with the same goal were bumping up to each other, which caused longer training. Next one. So our methodology can be concluded as a quantitative and qualitative because we've used the numerical values for the agent's actions, and we were exploring and experimenting with the agent data. Next one. For the data collection, the agent training was used with the proximal policy optimization. It is algorithm that uses the balance between new actions and new most of the points. Next one. Here are the ER diagram for the classes and games in game that we have. Next page. For the in this slide, you can see the cumulative reward history for the agent with behavior coding. The phases are going from top to bottom. So as you can see, at the start it was somewhat stable and it was performing normally, but after some changes in the environment, it went worse than it was before. Next one. In this, you can see the cumulative reward history for the agent without behavior cloning. At the start, it was stuck with the low amount of points, but going through a lot of phases, it actually started to perform more than like 2,000 points at the rewards.
Excellent. So let's talk about research limitations. Main limitation was that we're not modeling our AI by ourselves. We are using just existing technology that's called Unity ML Agents kit. So we are restricted with the features that with this library, Unity library, and the second limitation is training AI, especially in games. It's time-consuming, resource-consuming. So let's talk about results and the discussion. So as I stated, first result is training AI in games, especially in games. They are time-consuming, resource-consuming. It requires to have your machine high CPU usage. So the second is whether add AI to your game. It depends how hard is the game. For example, for some cases, implementing AI in your game could be easy. Sometimes it can be harder, and sometimes maybe you make AI so hard, so that can be unbeatable for any player. So it will, of course, it won't be affect the players' engagement. Next slide, please. So that updated. So okay, conclusion is basically the same, that with the result, it's just a brief. So agent is training maybe really complicated. So how hard was game? So it can cause the like time consuming and more training. And the third is whether you want to add your game AI. It depends how hard is the game. So the next slide.
The references.
Yeah, there should be references that we stated. And thank you for your attention. If you have any questions, feel free to ask.
Or this game into like
But yeah, you can go.
But actually, you think that this kind of artificial intelligence included into the games would make players more involved into the area and make a higher ranking for the games, because games with artificial intelligence could be more attractive for people. Yeah, but how is it possible to your approach to make, for instance, not games but study more attractive for users?
So actually, in the literature review, we like also use that, like we mentioned, that this study can be like better for those who want to try to implement the automated vehicle, like Tesla. Do you know Tesla? That is like driving by itself, car driving. Yeah. So our like training method and its conclusions maybe like used in those researches. So it is like actually media and study at the same time.
Okay, because now actually we have troubles with people who are, especially with children who are involved more in games than in the studies of the schools. So maybe if you include this kind of research into the scholar courses, maybe into some study courses, it would be much better than include them into the games.
Thank you very much. Thank you very much. The next presenter is Almas.
Да. PDF. Okay, hello everybody. Hello dear audience. My name is Ivan Andranov, and I will be presenting today our research on the topic of mobile application of convolutional neural networks for melanoma classification. I performed this research with my partner, Asalaya Beko, but she's not here currently, so I'll be representing both of us. Yep, next slide. So here you can see the outline. I'll cover the introduction, problem stage, literature review, project methodology, results, discussion, conclusion. So let's talk about skin cancer. Skin cancer is still a very prevalent problem in the modern society, even though melanomas and other types of skin cancer have been studied thoroughly, and the mechanism of skin cancer is well understood. There are still cases in some countries and still cases in some regions of different countries where skin cancer is not yet well researched or well understood or can be detected in early stages. So next, please. So this is part of our problem statement, is that the project addresses the present problem in the field of dermatology, so that being skin cancer, and healthcare accessibility. One of the biggest problems with skin cancer is that even though people know about it, it's very hard to understand and see it, because skin cancer, specifically melanomas, can be mistaken for birthmarks. And it's really hard to see it, even if it's like on your skin. It can also appear on different parts of your body that you don't often see as well. And another part of the problem is that even if people know about it, people might not have the tools or access to healthcare facilities that could provide such services. So this is the problem that we're trying to address. Next slide, please. So let's talk about the literature review. So first of all, we reviewed the literature about skin cancer. We had to understand how it looks, what it is, and what is the mechanism of skin cancer. We covered different supplementary materials, different information materials, and just understood what it is. Next, we are going to talk. Next part of our work is the convolutional neural network. Convolutional neural network was chosen as the perfect mechanism, the perfect tool for detecting and for determining, and well, not diagnosing, but at least just seeing if your spot on your skin is actually skin cancer or if it's just a birthmark. So we covered some literature there as well. Next slide. Then we talked about cameras of dermatoscopes and smartphones, because usually the way you determine, the way you detect skin cancer is by using special tools, which are called dermatoscopes. Dermatoscopes have very specific setup, which again contributes to the lack of access. Not every hospital institution, medical institution has those types of tools, which can be very, which can prevent medical professionals from determining if you have skin cancer or not. And then we compared cameras, lenses of dermatoscopes and smartphones, researched some literature in that area. And of course, last is the mobile development, which is also a part of our solution, because we believe that almost everybody nowadays has a smartphone. Even people in like far areas in Kazakhstan have that some type of smartphone, which may be based on Android or on iOS. And we believe that mobile development of an application would be a great solution. So here's our methodology. This is the data collection. We had only 1,300 images because we used the publicly available open access dataset from the International Skin Imaging Challenge from 2016. Here you can see the division. of these images. So we had a training set, test data set, and also we had a validation data set. Next slide, please. Because we had so little images, we had to perform different data augmentation techniques. Basically, we used image resizing, we used image cropping, we used image mirroring, image rotation, so that we could, out of 1,300 images, we could make new data, new change data that could contribute to the training of our model. Next slide. Here is the final architecture. You can see here the layers performed. Included in our model. The way we developed this architecture, we took the working architecture of from another research, and then we subtracted different layers and tested out different hypotheses. Like, for example, we added this layer here, we added this layer here, and we performed multiple iterations of our model, and like we saw which one performed better overall, and chose the best one. Here's an overall architecture of our model. It only involves 2 cumulative layers and a fully connected layer at the end. And another biggest part is that we use a non-standard activation function in our architecture. Here you can see the definition of that function. It is based on a hyperbolus tangent, which also includes the subclass function. This function is quite often used in the dense layer of neural networks, but here you can see that we're also using it for activation function. And here you can see the developed demo or developed model of the application that we will be trying to develop and deploy. It's not yet deployed, but it is in our plans. And next slide. Here you'll see these are just different screens, usually for diagrams and so on the application. Here you can see the results. Essentially, here is the accuracy for the validation data set. You can see that at some point it skyrockets and reaches great result after the fifth iteration. And here is the log function, which you can see steadily decreasing throughout the learning training process of the model. And here are the results. And here's essentially our proposed model. Achieved high accuracy of 80%, which is still, in our opinion, not high enough, especially for such crucial cases like skin capture, because you would want to have a better accuracy, but we're still planning on improving our model and improving the accuracy, and maybe expanding the data set, which would also improve our accuracy.
Thank you very much. Time is over.
Yeah, I have questions. Actually, I have several remarks on your data set.
Yes.
Actually, one of the most important feature about the cancers, all kind of cancers, is the speedy growth. They are growing, yeah, very speedy. And for instance, in your case, or in other cases, it would be quite usable to have pictures not only at some fixed point, fixed time of some melanoma, but at some subsequent steps of development of that melanoma. If you had this kind of data in your data set, if you take into account the velocity, the speed of the growth of that cancer, maybe you would have better results. But why you didn't consider this kind of study, this kind of classifying your data by their timing?
So the reason is because the goal that we wanted to achieve is that you take the picture of your skin, and by this picture you can instantly guess if this is cancer or not.
But actually you could take different picture after 1 week, then second week, and so on. You know that people do not pay much attention to their skin sometimes. Maybe it will be usable, for instance, take picture and then the program take another one after weeks, and maybe the programs will say you that it's dangerous, please check your skin and so on.
Yes, I think this is a great idea, and actually I will write it down. But for this research, we were only considering this case that you just take a picture and then you get the percentage.
But actually it was possible. But actually it was possible to do the following. If you know the standard growing speed for the cancer, with how it is growing with time, it's no fear. You know how it will grow for in average.
Yes.
Then you can, for instance, pick up one picture and you will make it higher and higher and produce another pictures that lights up at several times. And use this as some artificial training data.
You see, so I don't think I will have to do some additional research because I don't think there are data sets that involve include that type of data.
But it's able to make some additional research.
I think so too. But another problem that I can see is that people, when they're making photos, they're not making them in the same conditions. Like the lighting can be different.
It would be a big problem. For instance, you could make another additional problem to compare it to conditions and reduce them to one.
Yeah, you could like pre-process the images as well.
Yeah.
And so
Just will need some pre-processing of the different images. Okay, thank you.
that was a good idea.
How do you explain the low recall?
So what?
Low recall.
Yes, the low recall, we had very low recall data. We believe that actually the results from this presentation, I'll have to admit, they are a little outdated because even after we published our paper, we continued the iteration of models. We reached better F2 scores, but in this, at this point, when we published this research, the F2 score was horrible, like very, very low. We can explain it because we believe that the cause of that is that our data the size of our data set was quite low. 1,300 images is not enough for this type of model. And it's doing good when it's doing good with the задача, with the problem of determining when you don't have cancer, but it's not doing well with determining whether you actually do have cancer. So it has very huge amounts of false negatives, which is a huge problem, and we will address it in the future research as well.
So you focus on overestimating.
Yes, we would like our model to actually produce. It would be more beneficial for that type of model to produce more false negatives than for it to produce false positives.
Thank you very much.
So I have just only like quick one question. So you mentioned that in this page there are two convolution layers used. Okay, so do you have any plans to increase the number of convolution layers?
This is another limitation, as well as a previous group stated. We didn't have computational resources, and with the increasing of convolutional layers, the computational resources also increased. So we were already spending a lot of time training different iterations of the model.
I just want to inform that we have high-performance computing, like 10 computers.
I know, but I guess during this research I was using my own resources. So yes.
Thank you very much.
Thank you so much.
So, thank you. Jas, are you ready?
Yes.
Yes. Okay, can you please turn on your camera and show your share your screen?
Do you see translation?
Yes, you can start.
Hello everyone, my subject name is Development of Pneumonia Detection System on X-ray Images using Deep Learning. And my partner's name is Inkar Bazarkulova. So, our paper delves into the creation of a sophisticated system for detecting pneumonia using deep learning techniques applied to X-ray images. with the aim of improving diagnostic accuracy and efficiency in medical settings. By harnessing CNN, convolutional neural networks, the research exploits deep learning's ability to automatically discern complex patterns with X-ray images and a diverse data set of chest X-rays. Also, additionally, our paper addresses the challenges encountered during development, such as data variability, and for comprehensive dataset annotation. So we initially dataset consisting of X-ray images totaling 1 GB in size was thrown onto a local computer, and the road map of our work. So first is also data pre-processing. The dataset obtained required through pre-processing to address an inherent imbalance, and this pre-processing involved several operations, including resizing all images to uniform 150 to 150 resolution and normalizing pixel values within a range of 0 to 1, and applying data augmentation techniques such as rotation and zooming, and dividing the dataset into separate training, testing, and also validating sets. So the model structure was built utilizing the Keras sequential API, and this architecture comprised a sequential network composed of convolutional batch normalization, flattening, dropout, and max pooling layers. And also training of the model, next part. Commented after the preprocessed data were passed through the constructed network through the phase, the model acquired knowledge of complex patterns and data sets. Evaluation of the model performance was conducted using the validation data set. Also, this image offers a glimpse into the execution process, emphasizing CPU utilization and the component processes during case stages. It's notably leveraging GPU for computation, markedly improved computational efficiency. Also, in research, the model was trained using a data set obtained from Kaggle competition, and it's consisting of 5,863 X-ray images in JPEG format, and these images were sourced from the Guangzhou Women's and Children's Medical Center. Our model, it's the proposed deep neural network models architectural design outlined in our paper is visually depicted in this picture. The model integrates various essential techniques such as convolutional layers, batch normalization, max pooling, dropout, and flattening layers, which work together to accomplish its goals. And in total, the model comprises 1,246,401 parameters, with 1,245,313 being trainable and other non-trainable. The implementation of this architecture was facilitated through the use of Keras sequential API, which provides a straightforward methods of construction neural network. So,
Yes, 1 minute.
What?
1 minute left.
Ah, okay.
minute, you can conclude.
But can I continue?
Yes, you should conclude. You have 1 minute.
Okay. What I use formulas, precision, recall, and F1. It's formulas and our results. And the training process of the model extends over duration of 2 or 12 epochs, encompassing a total time of 26 minutes. And in conclusion, the system correctly identified 204 cases as having money, and the model integrates multiple layers and techniques such as convolutional layers, pooling, dropout, and the rigorous data pre-processing, including scaling, augmentation, and normalization, has bolstered and the ability to handle various types of chest X-ray images. Thank you for attention.
Thank you very much. Have you any question?
Yes, I have a question.
Yes.
So I think it's interesting work, but what is you know accuracy of your method? Yeah, so because we didn't have time to explain, I guess.
Yes, accuracy, we reached to 90%. And
so you showed on previous slide, right? Something.
Yes. 1 minute. Yes. Oh. First picture is training and validation accuracy, and second is accuracy and loss function.
Okay.
Thank you very much.
Actually, you know that it's not a very new problem. It's quite old problem, yeah, because the checking of pneumonia by X-rays are very general way to check the illness. So I didn't see the comparison of the results. Is the results much better than previous work on that direction? And what is the main advantage of your study, of your research?
It's our research. It's a new model. I think it's a model. Can you hear me?
What is your contribution in the field? Asked Bolgasha Gafurovna.
Comparisons.
What is the principal? What is the principal novelty of?
Principal novelty, I think it's nowadays pneumonia is so.
Yes, in comparison to other studies, previous studies, how your result is different.
I think at this moment, I think the I don't compare with other works, and it's next. I think next work I full compare with other works and advantages or disadvantages of our work with other works connected to pneumonia.
Thank you very much. Just for recommendation, use baselines and compare your results with their. Thank you very much again.
Okay.
The next presenter is
ID 76, Vladislav Kotsovsky. Are you here?
Yes. Can I share my screen?
Hello. So, no, not yet, just,
we see you, and please share your presentation.
Thank you.
Okay, what's all okay? Start, please.
Can you see my screen?
Yes, yes.
We can.
Thank you. Hello, my name is Vladislav Kotsovsky. My photos are Tatiana Lisovska and Vladimir Sabadosh. Let me to present our work, multi-threshold neural units for multi-class classification. In the current slide, you can see the statement of the goal of research. The first is the study of the model of multi-valued multi-threshold neuron suitable for multi-class classification. And the second is the design of learning algorithm for such neurons and the study of their performance. Next slide describes model of K-threshold multi-valued neuron with n-dimensional light vector V and k-dimensional threshold vector P. Single output is defined by equation 1. Using K-threshold activation presented in the slide. The illustration of the performance of three-threshold neuron in 2 dimensions is presented in the right-hand side. The neuron performance is defined by parallel hyperplanes H1, H2, and H3, which make partition of 2-dimensional space by 4 parts. Current slide explains the initial reduction of the task from partitioning of K separable finite sets A0, A1, and so on, AK. The pseudocode reduction process is given in procedure. This procedure allows us to reduce the initial task to the solution of the homogeneous system of linear inequalities. To modification of the relaxation by the learning algorithm will be considered. In the slide, the pseudocode is presented of the offline version of the learning algorithm. Online multi-threshold has 4 main parameters: an ordered partition, the number of learning epochs, initial approximation, and eta, the shadow function that defines the behavior of the learning head. In the next slide, you can see the description of the offline version of the learning algorithm, which is based on the use of the spectrum in the main correction step 9 that is performed once per each learning epoch. We also stated 2 theoretical propositions providing conditions, ensuring the finiteness and the successfulness of online and offline multi-threshold algorithm respectively. Current slide presents the simulation results of the performance of multi-threshold neuron yielded by about 2 algorithms compared to some classical classifiers. Both multi-threshold algorithms performed well on 3-class classification tasks, balanced scale dataset. Classification on the medium-sized drive-in dataset was more difficult. Multi-threshold neuron yielded by offline version performed better. The neuron produced by online algorithm and had the best accuracy among all considered neural-like, but its accuracy was worse than in the case of police classifier. And our conclusions. The main conclusions is that online version of the learning algorithm with a single multi-threshold neuron is simpler and often faster. but the fly modification usually is more expensive and can yield the neuron with better accuracy of classification. Thank you for your attention.
Thank you very much. Have any questions?
Yes, I have
Thank
question.
You have mentioned multi-class and multi-threshold. What does it mean, the multi-classes? How do you estimate if the situation is for multi-classes or not? Because in your example, you mentioned only algorithm applied for 3 classes.
Multi-class is generalization of binary classification is the case where the number of classes is greater than 2. And multi-threshold that neuron models which use 2 or more thresholds.
И это много или нет?
В каком смысле?
Multi-класс. Multi это много классов.
3 это много, все, что больше 2, это много.
Больше 2 считается много. Okay, thank you.
Thank you very much. So,
Other questions?
okay.
Yeah, I have
that's
question.
good. Okay, thank you.
Yeah,
Please.
question about weights. So you showed weights. How the weights are assigned?
Please repeat our question. Sound is.
So you have weights, right? W1, W2, W3. How they were assigned?
Light correction for both algorithms is described in the paper. Both use appropriate modification of the relaxation learning rules. Initial approximation is random.
Are you satisfied with the answer?
Yeah, I think it's okay. Yeah, thank you.
Thank you very much. Thank you very much. So the next presenter, Tamerlan Mendebayev, Abulkhair Mendebayev. Are you? Okay, thank you. Please share your presentation.
And we cannot hear you. No, we cannot. iPhone 4, yes. We cannot hear you.
Tamerlan?
I'm Abulkhair. Can you hear me?
Abulkhair?
I'm okay.
Can you hear me? Yeah, now we can hear
I
you.
have 2 different accounts for Zoom because I don't have a video camera on my laptop. So,
Yeah,
is
you
it
can
okay?
continue, so just share your screen.
It's okay.
Share your screen. So you have 7 minutes, Abulkhair.
Okay. My topic is assessing urbanization level using geodata, implication for Kazakhstan regional development planning. So in this study that utilizes satellite data on official statistic and analysis of the level of urbanization in Turkestan region was taken. There are several differences between the official results and results that I found in during our research. we challenge the assumption that Turkestan region highly urbanized and sheds light on a different perspective on its development. Because a considerable portion of the region doesn't qualify as a functional urban areas. So also I'd like to highlight the need to address the complexities of urban development by using available open data. So, okay, let's go to methodology. The degree of urbanization methodology is comprehensive framework for classifying territories along the urban to rural. So it relates to population size and density thresholds. By utilizing specific calculation cells, the methodology delineates various urban classifications. So it divides by cells. For example, urban centers are characterized by contiguous cells, showcasing a population density exceeding 1,500 inhabitants per square kilometer, and overall population over than 50,000 individuals. Urban clusters are comprised of adjacent cells where density is 300 inhabitants per square kilometer and a total population exceeding 5,000 people. Also, there are rural settlement cells, which means that density is fewer than 300 inhabitants per square kilometer with per square kilometer. So there are a picture of city Aksukent. In the red area, we can see that a high level of connectivity and accessibility within the city because of efficient urban planning. Also, during our analysis, we found that 3 cities of 7 in overall didn't meet the quality to be a city, and we find it rural in terms of functional urban area. Functional urban area refers to territorial unit that emerges from the organizations of social and economic relation within an urban region. So the concept of FIUA highlights the interconnection and independence between urban and rural and surrounding regions. So to conclude, the hypothesis put forth in this research was fully sustained as distortions in initial data exceeded staggering 54.1%, indicating significant flaws within the state planning system. So findings of this study indicate that 3 out of the 7 cities in the Turkestan region have lost their status as functional urban areas. And also the total population of 2 million, approximately 397 and 6,000 rural people are considered to be living in urban areas. So there are results underscore the pressing need for a comprehensive evaluation of overhaul of Turkestan region administration. Okay. Also, the implications as a study expands the application of methods previously used in similar research, and the results show that the actual level of urbanization in the region is less than official figure of 56.7%. So we found only 36.9%. Okay, such significant difference between the state-approved data and measured level of urbanization raises questions about accuracy of the data and methodologies used to determine urbanization. In other words, it means that open source data and official data has a lot of difference, and it's equal to almost 20%. So that's the main idea of implication. That's all.
Thank you very much. Questions, please?
Oh, wait.
I have a question. Can you forecasting? Can you forecast in what reasons for such difference?
I think the main reason is the way how it was determined by. I'm sorry. Can I? I mean that the way
you explain.
I hear myself, and it's disturbing. I'm sorry.
Okay.
Can you? Yeah. Okay. Nice. I mean, the main way why there are such significant difference, it's because the way how the government research was provided, because there are a lot of data that doesn't apply to nowadays. I mean, it would be great to do new research with modern ways. To use a modern methodology. Okay. That's all.
I'm sorry, maybe you didn't understand what I asked. Actually, I asked behind excluding accuracy, are there other reasons for such difference?
I think
maybe you can.
Okay.
Okay. Maybe you can show other reasons excluding data accuracy or excluding data availability.
Yes. I think there are another reason in the mythology. I mean, earlier some experts used a way where they refer only for area or only or refer only or only on the density or other single single thing in single figure. I mean, they reflected only on single thing.
Thank you very much. Your topic is really important. So maybe Yerkin Abdildin.
Yes, I have short
You
question.
have a question?
So in your model, you show that some rural, let's say towns, right? Let's say towns become like a city, right? So what will give them if they become city? Who can use your work? Like, is it clear?
To be honest, I don't understand clearly.
So if you go to your slides results, you show that three towns
villages
become cities, right?
No. Through city, it doesn't mean the categories to be a city, to be considered as city. I mean, they actually in type of they considering as a city, but their parameters are not give them access to be a city, to be considered as a functional urban area.
Okay, so how your results can be used? How this result can be used? Who can use your work basically? What it gives, if they are city or not city? How it changes the life of these people maybe?
Yeah, it will help to change the lives of Turkestan region. I mean, also it can be used by the government. The study findings and recommendations for future actions probably will develop the territorial population and knowledge, and will help to in future to plan other urban projects. I hear myself again.
Thank you very much. The
Okay.
next presenter
Thank you.
is Janseri Kram. No time really. Thank you very much.
Okay.
Sorry. Janseri Kram.
Okay.
Are you here?
Yeah, sure. I'm here.
Okay, thank you.
Yeah, sure.
Turn your camera, please.
Just a second. So hi again. It's again me, and again with face anti-spoofing. But this research is more about achieving the best accuracy. Best, I mean, not accuracy, best metrics. So hi again, my name is Janseri Kram. I think I didn't turn on my video, so hi again. The topic is dual domain face anti-spoofing with integrated spatial and frequency analysis neural network. Actually, it's quite similar to my previous work that I showed, but I'll explain what did I improve here. First, why again face anti-spoofing? So by the by using different persons' photo or other video publicly available, the attacker can get access to the bank account, to his bank account, so we should secure. So again, background and motivation is so current anti-spoofing methods struggle with accuracy in varied lighting and environmental conditions. Many remain ineffective against novel spoofing methods. So if we add different the methods, I mean, not as different attacks from different domain, it can easily the system can be easily hacked. So the visual, I mean, the number shows here. So NIST evaluated on last year. So they showed us that the best company shows the average error rate around 12%. So this company is still working on the market. A lot of banks use their system, despite that this company has the error rate 12%, so average error rate 12%. So still the work the topic is hot. So so actually the traditional face anti-spoofing, I want to show here why they don't work. Not why, but what methods don't work already. It's called local binary pattern. They use feature histograms to analyze or eye blink detection or surf descriptors or other Hawk gradient based face analysis. All these methods don't work already, so we need to improve the methods. So I use here deep learning. Again, the data set is from OLU-NPU dataset. The videos are around 5K, 5,000. So this how looks my dataset. And the metrics here are APCR. The first metric is similar to false positives. The second one is similar to false negative. Here, ACER is the average between them. So in face anti-spoofing, these metrics are defined in such a way: attack presentation classification error and bona fide presentation classification error. So if you remember, the architecture looks like this, but here I focus more on getting the best results, so close to the state of the art. So here I more focus. I put focus more on the Fourier hit. I try to optimize and I try to get better branch here. This branch looks like this. So it has 6 convolutional layers with batch normal ReLU, and this section, the first convolutional layer gets the features from the third block. Here you can see, from the third block, and tries to again restore the map at the end, restore the Fourier map. Why Fourier? I didn't answer this question, by the way. The Fourier is really helpful because it catches the pattern called Moire effect. You can search for it. It's called Moire effect when you, for example, shot the video of different display or monitors. You can see the lines here, and it's called Moire pattern, and Fourier transform can easily catch it. So I adapt this method to my architecture. So the experimental setup here is a little bit different. So the optimizer is ADAMW. I used scheduler reduce learning rate on plateau, trained for 100 epochs with batch size 32, and the image shape is 384, and I averaged 10 frames per video because I'm trying to get the best result, but not focusing on time. So this is my result compared to other researchers. I actually showed these results in my paper. If you're interested, you can look at this. All these methods are deep learning methods, not classical machine learning. And as you see, I got very good results in all 4 protocols. By the way, I used all 4 protocols. So these results can be interpreted in such a way. So it demonstrates strong adaptability to new lighting backgrounds. So it also showed good results when you change printers and displays. Also, there is one protocol which is called leave one camera out. When you change the camera and when you don't use this camera on your training set and put as a different domain. And the fourth is generalization to diverse environmental conditions, attack methods, and camera sources. So in all these methods, the model showed very good results. So here are the conclusions. So I use combined loss. So best results on all. And that's it. Nothing to add.
So thanks for your presentation. So do you have questions? No questions, no. So people, yeah, so Zamshira, my concern is, I think in your two papers you were using the same data set as.
The data set is the same, but the methods and the experimental setup is different. On the first paper, I focused on, as I said, on efficiently inferencing. So I could, I can hear myself. Could you turn off your microphone, please? Yeah, thank you. So on the first paper, I did the efficient architecture, so I could use it on mobile devices, for example, in the future. The second one was to beat all these methods, to get state-of-the-art state-of-the-art model. Yeah, according to these metrics.
Thank you. So other questions? No questions. So thanks for your presentation. So
Yeah,
ID
thank you.
80, ID Tohtarova.
Thank you, bye.
Bye. Aigirim Tohtarova, Danyar Svetan Janar Ajibekova, are you here? Hello.
Yes, hello, hi.
Yes, hello, hi.
Yeah. Can you see my presentation?
Yes, we can see, we can continue.
Oh, okay, thank you. This, hello to everyone. My name is Aigirim Tohtarova. I am a PhD student. So today I want to present about the view of machine learning models in cyberbullying detection problem. Oh yeah. Cyberbullying has emerged as a significant concern in the digital age, posing threats to the mental and emotional well-being of the individuals, particularly adolescents and the young adults. This paper presents a comprehensive review of machine learning models employed in addressing the cyberbullying detection problem. So here we can see classification of cyberbullying types in a social network. There are many types of harassment, denigration, flaming, outing, and trickery, exclusion, and impersonation, and cyber stalking. There are many types. So now we can you can see that data collection and applying machine learning for cyberbullying detection. To develop an effective cyberbullying detection model, the first step involves collection data from various online sources such as social media platforms, forums, and messaging apps. This data often includes the text and the multimedia content, user interaction, and metadata associated with online posts. Now let's talk about the steps. So first of all, we need to parsing the data and structuring. Raw data collected from the online sources in typically unstructured. Feature extraction is a crucial step in preparing the data for machine learning. Dataset creation, the structured and the feature engineered data is divided into training, validation, and the testing datasets. So here is binary or multi-class classification. Cyberbullying detection can be framed as both binary, multi-class. For example, if we say for binary, identifying a post is cyberbullying or not are for multi-class classifying different types of cyberbullying. Reject and accept decisions. After model training, it is essential to set the threshold or decision boundary for classifying new unseen data. Collection data from social media space. Continuous data collection is crucial in the dynamic online environment. Model fitting and iteration. Based on the testing results, the model may require further fine-tuning and optimization. So developing cyberbullying in detection model involves a series of steps from data collection and pre-processing to model training and evaluation. So now let's talk about feature engineering. In the realm of machine learning-based cyberbullying detection, the foundational building block lie in the creation and the utilization of feature vectors. Features, quantifiable attributes of observed tasks serve as a bedrock on which machine learning algorithms relate to differentiate between virus classes. So this article have eliminated the relationship between virus features such as gender, age, user character, and the prevalence of cyberbullying. Here we can see summary of feature types used in cyberbullying prediction literatures. There are I take about 10 literature and I checked which machine learning algorithms use it in there. So now let's talk about machine learning in cyberbullying detection. The most frequently employed machine learning techniques for constructing cyberbullying prediction models include like support vector machine, naive Bayes, random forest decision tree, k-nearest neighbors, logistic regression, radial Bayes method. So there is evolution of metrics. Evolution of metrics.
Again, a minute left.
Evolution of metrics. Okay. There is accuracy, precision, recall, and F1 score. So thanks for this. Thanks for these four fundamental concepts. Accuracy, precision, recall, and F1 score are equal to the common performance analysis evolution metrics for classification task. So let me conclude it. In conclusion, this research paper has navigated the multi-faceted landscape of cyberbullying detection on social media. The critical role of feature engineering and selection features has been emphasized, underscoring their impact on the model performance and providing a quantitative framework for evolution model effectiveness. The importance of robust evolution metrics was explained. This research paper contributes to the ongoing effort to mitigate cyberbullying, providing a foundation for the development of more reliable and efficient detection mechanism that fosters safer online environments.
Thank you. Thank you very much. Have you any questions? I have one question. So, what's your recommendation for such systems, especially for Kazakh language?
So this is my research work nowadays. I am collecting a data set from social networks for Kazakh language. So I am working on it.
Maybe, maybe important features depend on language. What's your opinion?
Can you repeat the question?
Is your opinion about depending on the language, depending features on the language?
Yes, for example, for English language, is easier to find this word consists cyberbullying text or not, because the English language is popular. That's why the machine learning algorithms work on it very easy. But for Kazakh language, we have to build from the low
We have no
step. Yes, there is no any data sets like that. So we are taking it from the zero. We are building from the zero.
Мы вас не слышим.
We do not hear you.
Can I ask one question?
Thank you very much. The next presentation is paper number 83.
Yeah. Hello, this is my paper. Yeah.
From Ukraine.
Hello, could you please turn on your mic? I think we cannot hear you.
Мне кажется, это наша
Can
проблема.
you?
Мы перестали
Can
всех
you?
слышать.
Yeah. Maybe someone can ask in the chat. Hello, hello, hello.
Да, уж космос тема.
I can hear you, but maybe anyone can set. Anyone can hear me?
Sorry, we do not hear you.
Okay,
На
just a
нашей
second.
стороне проблема.
Please
Maybe.
wait a bit.
Yeah. Can somebody set? Is somebody hear me? Oh, yeah, yeah. So someone can hear me. So yeah, maybe on your side.
А здесь телефонно? Телефонно? Казал Москва танц раньше.
Yeah. I just write on the chat a message. Yeah. Hello, hello, hello. Hello, hello, hello. Can you hear me? Hello, hello.
Герим Алмаз, а вы слышите то, что говорит Юрий?
Hello, 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 hello. 1, 2, 3, 4, 5. Yeah.
Да, слышно.
Hello, hello, hello.
Мы не
hello.
слышим. Юрий, остановитесь, пожалуйста. Зовите этого мальчика.
Может, что-то случилось с этим воспроизводящим?
Hello. Can you hear me? Mhm. 1, 2, 3. Oh, yeah, I can hear myself. Yeah? Everything correct right now?
Да, мы вас тоже слышим.
Yeah, nice. Okay, can I start? So, can you see my screen?
Yes, we can.
Cool. Okay. So I'm happy to be here. Let me just expand this. So my topic and our topic is an optimal gradient descent algorithm for LSTM neural network learning. So about the authors, it's myself, Yuri Khodlevsky. I'm a PhD student, and Tatiana Vakluk. It's a doctor of science and professor and head of the Department of Software Engineering in Zhytomyr Polytechnic State University, and we are from Ukraine. So let's dive deep a bit inside our background of our problem. And we are working on developing some system for monitoring by some factories, some stations. And imagine that you can have some factory. Inside this factory, you can have some different equipments. And inside these equipments, we can install some sensors and collect the data from this sensor and save it to the database. And we want to build a system that can use machine learning algorithms to detecting anomalies inside these systems. So in fact, the data from a sensors, it is simple time series data, and we can analyze it with different techniques. And for example, we can set a maximum or minimum for the graph. And for example, if some data is increasing these limits, we can detect an anomaly and send an alarm. But in a case of the third and the second graphic, it just won't work because we can have some anomalies inside. So we pick up some regular LSTM neural networks. Also, we are trying to work with regular recurrent neural networks, but of course, regular RNN can have problems with expand or vanishing gradient descent. So we pick LSTM as an optimal architecture for our neural network. But we faced with the problem which gradient descent to choose. And we are closer now to our topic because we're using TensorFlow, and TensorFlow providing to us some regular algorithms like stochastic gradient descent, RMS prop, NADAM, ADAM, ADAGRAD, ADADelta, and etc. So we need to pick up in some way which gradient descent to use to get optimal results of prediction time series, and after this finding some anomalies inside this time series data. So what we did, we create some strategy to choose optimal gradient descent, and we fix some rules how we can do it. First of all, we propose that it is necessary to make 10 experiments for every optimizer. And also we limit our neural network by using only 50 LSTM units and just 10 epochs for training, because sometimes we can use calculation on some small machines, on some edge devices like Raspberry Pi or Arduino, etc. And so we limit it in some environment. So we pick up the minimum units and the minimum epochs to find optimal gradient descent. So, and we also pick up 4 main metrics, which we based on. It's a mean squared error, MAE, mean absolute error, root mean squared error, and R2 score. So based on these 4 metrics, we can pick up optimal gradient descent. And after all experiments for every optimizer, we will have some experiments for every optimizer one by one. And by calculating all these metrics, implement our algorithm to find an optimal gradient descent, we can have just one value, which is indicate the optimal algorithm for our learning. So here it's just regular formulas for these 4 metrics. And let's dive deep into our experiment structure. This is an example of one experiment for SGD. It's a stochastic gradient descent. So we are training our model with a fixed LSTM units and fixed epochs. After this, we are grabbing 4 metrics and save it into a database. Here we can see the process of learning of our model based on loss matrix MSE. It's just an example to visualize what's going on inside. And here is actual and predicted value. Okay, it's just one experiment, and we repeat this experiment 10 times and can calculate all this data. After this, per every metric, we calculating an average and also saving it to database. As a result, we can see the table, and by the information from this table, we can choose by the final score an optimal gradient descent algorithm. So, for example, let's dive deep into this table. We pick up SGD, make 10 experiments, calculate MSE, MAE, RMS, and R2 score, calculate the average from 10 experiments, and after this, we calculate an average per every matrix, and we are getting a final score. Based on this score, we can set that this is a score, final score of accuracy of yeah, sorry.
1 minute left.
Yeah. And we can have a final score. So based on this score, we can get a minimum value, and corresponding algorithm to a minimum score is the optimal algorithm of gradient descent for LSTM neural networks. Also, we after all our experiments, we make final experiment to see how it works in general. So we can see that loss is close to 0, and our predictions is pretty close to actual values. And also, someone can say that our model is overfitted a bit, and I can agree, because this data was synthetic generated, and that's why we also make experiments with real data from temperature and by the time series. So we calculate the temperature, make our final decision to use Adam in our LSTM, and see the results. So thanks for your attention, and I'm waiting for your questions.
Thanks for your presentation. I have a question.
Yep.
Do you hear me?
Yep.
Okay. When you mentioned about
Yeah, I cannot hear you. Sorry, I cannot hear you.
when you say about the optimality, you need to introduce some kind of the cost function, yeah?
Yeah.
In your case, it turns to be the measure, maybe the accuracy of the solving after 10 epochs, yeah?
Yeah.
But I think when you apply the gradients method, there is a big difference of the computational cost for each method, the first one, and the second one, the number of steps you have to apply that gradient method. So maybe it would be better to compare different gradients method by taking into account the computational cost and take into account the number of steps that you have applied to use the gradient method, different gradients method, to compare them. Did you understand me?
Yeah, that's a very good question, because we also planning to do some estimation using big O notation to calculate.
Sorry, we do not hear your answer.
Yeah. It's again maybe with your site. Can anybody hear me?
Можно же не просто достичь какой-то точности.
Yes, we hear you.
Какой ценой? Сколько шагов сделать и сколько операций, чтобы достичь
Yeah,
10 эпох или...
Can you hear me? You can hear me, yeah? I cannot hear you, but anyone else in the meeting can.
Sorry, we cannot hear you.
Yeah.
It's okay.
Yeah. Hello. Yeah. Hear me now?
Okay.
Just say. Oh, yeah, I hear myself. Okay, yeah, about computation steps, it is very correct answer, a very correct question, sorry. And I agree that we need to calculate it, and it is planned for another research to use big O notation to calculate the computation resources that we're using into different gradient descent algorithms. So yeah, it is planned to realize this match into the next research.
Thank you very much. So the next presenter is 106. 106.
Nurjan Omar Zinel Momkul.
Yeah, I'm here. Hello, everyone. Can you see me?
No, we cannot.
One second.
And also, can you please share your screen?
Yeah. One moment.
Don't forget that only 7 minutes. Okay.
Yeah. Don't worry. I try to be quick. Just a second. There's problem with my. I can't share my screen, I guess, right?
Yeah, but also you need to turn on your camera.
Yeah. I try and get some technical issues. I need to turn on my webcam. It's not usual way.
Could you please fix all technical issues before the presenting? Because IEEE will not accept if you will not turn on your camera during the presenting.
Yeah, I mean, I was presenting my previous presentation. Another section was good. I don't know why it's now not allowing me to show my
Could you please show?
web camera. Yeah, I'll try. Oh yeah, one moment. I guess I found it.
Denis Valyaev, are you here?
Yeah, I'm here.
I'm here.
Yeah, I guess one more after one.
If Zainel is
Yeah, I guess it's gonna be
out of our
The name.
Yeah.
Can we continue with Denis Valyaev? So after that.
Yeah. I guess gonna be good. Yeah.
Denis, please.
Okay, thank you. That's 1 minute, please.
Yes.
Just show you my presentation.
Нет, мы же должны остановить.
Oh, I can't share my screen. Oh, okay. 1 minute. Can you see my presentation?
Yes, thank you. All is good.
Okay. My name is Denis, as was said, and I want to show you our study, FMEA variables of software failures risk based on journals and metrics. So to begin with, software is integrated in all critical parts of our life. So we should consider and properly handle software failures. Of course, to do it, we should assess risks, and we should base it on objective methods. In other words, we should base it on analyzing real data. Our aim of our research is to develop and verify the software failure risk assessment model, and our objectives is to select models, formulate the final model of risk assessment, establishing an experiment, and make conclusions of it. So let's move on to the background. FMEA is a short of failure modes and effects analysis. Failure modes consist of causes and effects, and the main aim of this model is to calculate RPN, risk priority number, is a product of occurrence, detection, and severity. So we choose two data sources. Is Grafana Loki, is a database of journals of application execution, and Prometheus is a time series database which
contains contains metrics of executions. We developed data extraction level, and data analysis layer is implementation of our target model. So we started to analyze journal. We should group records by the same year. We used Jara-Winker similarity model for it. The next, we extracted time series from Prometheus and used Friedman supersmoother algorithm to identify a trend component and a MSTL decomposition to identify a seasonal component. So we subtracted from original time series these two components and we got a reminder. We applied interquartile range for reminder, and you can see on this slide interval this if a point inside the reminder went out from this interval, we consider it as anomalous point. And we have a final calculation of variables. Occurrence is a simple count of log error occurrence. Detection based on the average of similarity coefficients, and severity based on the average normalized difference between anomalous point and predicted normal values on the same points. So, and all FMEA variables calculate yes, all FMEA values of FMEA variables inside an interval between 0 and 10. So we established an experiment based on the virtual machine on DigitalOcean. We installed Kubernetes, and using Helm, we installed Prometheus and Grafana Loki. We developed an experimental application which simulates extreme errors with anomalous RAM consumptions. And using R, we implemented our model. So you can see results of this experiment. The first graph represents just the error occurrence with timestamps. This is experimental error, yes. And the second one is the RAM consumption time series. Gray line is the original time series, and red is the cleaned one. So when where you can see difference between actual and cleaned, this is anomalous points. So the last result is the FMEA table. We can see that our experimental error, which is rated as 3, and we have a noisy error from Grafana Loki itself. Yeah, there was some network problems of Loki, so we this model rated this error as 0, so as just noise. Oh, sorry. And as a conclusion, we have model formulated. It was found that the error that observed during 24 hours refers to the same error, and the system, in our opinion, system correctly calculated the FMEA parameters and identified the noise. So thank you for your attention.
Thank you very much.
I have a question.
Okay.
Yeah, Denise, your experiment showed the result of analyzing data collected over 20 hours. But can this model be applied to other time periods?
Thank you for your question. It's a good question. Yes, we are working for the next study, and we applied this. We have already applied this model by 7 days and 30 days, and yeah, we discovered that this model is stable, but this is for future researchers. So yeah, thank you for your question.
Okay, thank you.
Thank you very much. The next presenter is Zeynel. Are you ready?
Yeah, I can turn this on. Hi again. So can you see me, I guess? Right?
Yeah, we can.
And for my PT.
So you have 7 minutes, okay?
Yeah. I try as fast as I can, okay? Because I understood the situation. So hello everyone. My name is Monkol Zeynel. I'm a second year master student from MyETU. And my topic is detection of dangerous situation by sounds in real time using deep learning. And let's start off quickly with the idea of a project. So when our team started to think about something that can be helpful or different kind of situation, we analyzed a lot of video surveillance services and just compared to the human without any special additional gadget or devices. So the audio surveillance was one of the best our choice compared to the others, and these things based on disadvantage is detection in low visibility condition, like at night, compared to the video vision, where they should have something with the night vision, right? Technologies, early detection of sentinel events, that this can be really fast sometimes compared even to the, again, video surveillance systems. When to find, analyze a video, it should have a lot of space on some hard drive on servers, right? And at the same time, we have just the sound with just audio, right? So everything is a wave, so it just can simply be analyzed. And other one important thing is the cost and installation efficiency, because after our project is done, first part of our project is done, we continue to start to a second part with creating the device. I'm talking about a little shortly. If you want to know how it's happening right now, you can ask me after presentation as a question. And one of the idea was to analyze what is mono and stereo sound is. So why with a one channel sound sometimes can be better even to two-way channel with for the left or the right ears for the comparison, right? So you can see the image of the mono versus stereo channels or the sounds, right? So our study was more basically study on the every audio comparison between sound. So which features we can obtain during our research can be really helpful to analyze it in future. Also, I want to note that converting sound wave to array type was also important part of our study, because sometimes when we say, hey, we just plug the analog device into some audio perspective, we're just loading it, model is ready. No, it's not so easy to do in 1 hour, 2 hour as laboratory work from some university class, right? So we really deeply understood how we can gain information without any loss of or corruption of the data in the paper. And after that, we go into our data sets that finally happen to use it in our model. So we have two main data sets. One is the Urban Sound 8K, which contains about 10 classes. It's a good data set, but it's a little bit slow of the data. And we have some classes which is not can be helpful, like car horns, right? Drilling, engine idling. So we tried to collect our data set, which is called Urban Audio data set, with 10,000 samples with 8 classes, which for our opinion, it can be more useful rather than the first one. It's around 20 GB, of course. And after that, we applied the next features that in our study was one of the 5 best features that can be in the state-of-art models that are applying right now. So one of the short time for the transform, chromograms, a spectral contrast based on the STFT, mel frequency spectral coefficients, and tonal centroid features, also tonal coefficients. And there are 5 features that we're basically applying to our model. And to show it, we also tried a lot of time to proceed. So after that, we want to talk about the proposed model that we're sending out a file into the stage 1, which calls feature extraction. Then after we're saving the NPy file, an NumPy file for processing. And in the right, you can see the legend, what exactly happening on the screen. After we applying the first model, in our research, unfortunately in this paper, it wasn't covered all models, because we also tried model CNN LSTM, CNN RNN, with recurrent neural network, classical CNN, and other approaches like machine learning models. But for this paper, we was presenting our best model, which is CNN bidirectional STM model, which applying with CNN. And after that, we applying something called bidirectional STM architecture. It allows to model to grow deeply as LSTM, but in two ways. So we can start as a start with the data until the end. And it's the same as repetition every time until our data fully coverage. And this one is, we can say that the state-of-art model is used this approach, but we tried and it works good because our overall proposed model, you can see like this. So it's firstly going to CNN because we need to obtain the low-level information from the data. And after that, it processing to the audio processing as LSTM with the fully connect layers in the end and softmax as the last layer activation function. After we obtain the next results, it's about 90, next about accuracy, unfortunately, wasn't in this also slide. I'm just lost to add it, sorry. But it was around 95% of accuracy for each of the classes. And we have also obtained something around 0.3 of loss. And like peak as the best of the models, yes, state-of-art models are around 0.1, 0.2. So we like 0.1 difference compared to them. I guess it's kind of good. After that, we also try to create application architecture, which is fully covered by front-end, back-end systems, and also is a model with API application. I forgot how it stands for, so sorry, just API, yeah, that connect with the backend, that returns the predictions, backend stores some data about that, and frontend just can access to any point, yeah. And about libraries, shortly we're using Spring and Java for the backend, and we use a frontend. Next libraries for working on that. For the model prediction, we use the TensorFlow, and actually that's all. If you have any questions, I'm glad to answer.
Thank you very much. Questions?
Thanks, Dada. You have mentioned some sounds in dangerous situations. So actually, how many classes, how many classes of dangerous situations did you compare in your model? And how many classes did you compare in total when you make this kind of classification?
Yeah, our overall was using urban audio dataset. So we overall have next 8 classes, as you can see in the right part of the slide. So crying, dog barking, emergency alarms, explosions, fire, glass breaking, screaming, and sound of weapon firing. The problem of them is because weapon firing or gunshots was really low accuracy compared to others. It was only about 88% compared to other 95 or higher. But because the weapon firing, I guess we should also be classified as a subtype of this weapon. For example, it can be a pistol, grenade, maybe, yeah, shotguns and so on. And problem is it can be really variety of this, so it can be failing a little bit of this. And answering to your question, we used this 8 of them. If we some partially took from the Urban Sounds 8K some data because we wanted to create something really big data set, which is Urban Sounds 8K is good, but it's compared to the 10,000 samples with the 8,000. I guess our is much, I would say, more useful for our task rather than first one.
Thank you. Okay. The next presenter is.
Thank you.
The next
It's
presenter
me,
is
Kanash Maksat.
Daniyar.
Okay.
Daniyar.
Daniyar Sultan, are you here?
Daniyar, not here, but Maksat here. Maksat, please.
Yeah, I'm here. Can you hear me? Or can you see me?
I see you.
Could you please share your screen?
Yeah. 1 minute, please. Do you see my screen?
All is okay, please start.
Okay. My name is Kanash Maksat. I am our paid master student, and my paper's topic is the research of and development of an information system for speech recognition based on neural network algorithm metrics. My introduction. Our main aim is finding the best model for speech recognition and creating an application to compare them with each other. And our main objectives, our main steps, is first one, selection of models, then identify his strengths, his recognition potential, and next is comparing this model and get the results. So about relevance, now it's kind of breakthrough of some systems of services based on neural networks. and speech recognition services is one of big part of these products. For example, big companies kind of OpenAI, Microsoft, Google, performing kind of arms race between them. So now a little bit about algorithms. Here, 5 algorithms is gradient descent, backpropagation, CNN, RNN, and deep learning. Now about gradient descent. First purpose of this algorithm is an optimization method used to minimize a loss function. His working principle is update the model parameters in the direction of the negative gradient of the loss function. Then is backpropagation. His purpose is, it's algorithm for calculating the gradients of the loss function with respect to the model parameters. And his working principle is propagates the error from the output layer to input layer and updating the weights at each other step. And next is CNN, or convolutional neural networks. And his main purpose is he's using for processing data with a grid-like topology. And he also linked with next algorithm, RNN, using for processing sequential data. And last one is deep learning. So deep learning is a subset machine learning that focuses on training deep neural networks with multiple layers. How you can see on this image, they have a lot of layers. So now about my experiment. For the first, to get a good result, I have to prepare some audio data. And this data have some conditions to make a good result. For the first is a good quality of data, some external condition, accents, speech defects, and of course devices. Someone can record audio by professional microphone or it's telephone microphone, and it's a big difference between these records. So now I choose 2 recognition models. It's models from by Google and Bing. Actually, Google and Bing using CNN and RNN algorithms to train his models, but they have big differences between us. So in my experiment, for the first to compare these models, I have to find an distance algorithm. I have 2 variants: it's Hamming's algorithm and Levenshtein algorithm. Levenshtein algorithm is more flexible, has more flexibility. But Hamming algorithm is faster. I using Levenshtein algorithm because in my software you can exchange some models, and we need flexibility to perform it. In this picture, you can see the results. It's the results for Google recognition. Here, 2 tables. 2 graphs based on the recognition speed and accuracy. And same graph for Bing model. And in conclusion, we get application to comparing models. Of course, we can exchange models, and it's not kind of only Google and Bing. It can be Whisper, it can be Microsoft models and others. So thank you for your attention. Maybe any questions?
Yes, I have one question. Can I ask?
Thank you very much.
Yeah, please, Timothy.
Why Levenshtein algorithm is better than Hamming?
Levenshtein algorithm, yeah, thank you. It's a good question, but how I said, Levenshtein algorithm has good flexibility, and Hamming has a good speed. But in our case, we need to use the Levenshtein algorithm to exchange our models.
Okay.
Thank you.
Okay, thank you very much. If there are no any questions, we should finish our
Session for today.
Его нету. So,
Thank you for participating, participants. Have a
Thank
good.
you.
Yeah. So do you have other questions? Maybe you have.
you can have
You can join also for tomorrow's presentation. So with the same link.
the same link and continue our session
At the same time, yeah.
at the same time. So good luck for